In this lesson, we will investigate the concept of regression. The key concept in this section is to describe the linear relationship between two variables with an equation of a line that can be used to predict other values. This line is called several things: trend line, line of best fit, or regression line. What is a regression line? Well, you can look at a scatter plot and try to create a line that goes through the center of the values. This line of best fit is the equation of a line in slope-intercept form that passes through the center of the values, and it lets us make predictions. So slope-intercept form of a line is y equals mx plus b. In some textbooks, the regression line equation is y hat equals ax plus b. Some write it as b plus ax. Here's a graph showing a scatter plot, and we graphed a line of best fit, which allows us to make predictions for values that weren't in the original data set. This is showing attendance and parking, and so I can see, for instance, that for this particular point on the graph, between 100 and 150, so at 125, how many cars did I have? Well, I have an exact data point here that I can estimate the number of cars. But for an attendance of like 275, I don't have an exact point. So what I can do is I can graph this trend line or line of best fit, and I can go to 275 and I can go to my line and I can predict how many cars I should have in the parking lot with that attendance. The x variable in a regression equation is the explanatory variable, and the y is the response. So for the equation y hat equals ax plus b, the hat means it is a prediction equation. A is the slope. We're going to find this in the calculator, and I'll give some examples next. B is the y-intercept. This value is also found in the calculator. Both A and B are found just like we would find R. Okay, so if you looked at the previous lesson on correlation, I showed you how to enter in the data and find R, which is the correlation coefficient. Next to R, you're going to see A and B. The equation does not change even if we convert the values in our original data set to a different scale. The value is also not affected by the choice of x and y. So this is just a review of how we enter the data in to find R, and this is also going to show you how to find A and B. So first we need to clear all data, so we're going to press second data. Press second data again, then arrow to the right and do clear data. Once you've cleared your data, you want to set the calculator to two variable statistics. That's because we're going to be typing in paired data. Press data after you do that to enter in your numbers. After you've entered in all of your successive points, press the stat var key, which is next to data, to calculate. Keep arrowing to the right until you find A, B, and R. In predicting a value of y based on some given value of x, it's very important to first see, is there linear correlation? So we always take the absolute value of R that we get from the calculator and we compare it to the critical value that we can get from table A6. Okay, so the absolute value of R must be greater than that critical value. If it is not, then we cannot use a prediction equation. In that case, if there's not a linear correlation, the best thing that we can do to make a prediction is to report y bar. Now y bar is the average of the y's. In your calculator, when you type in all of your data and you're searching for A and B and R, You will also see y bar and x bar. So you don't have to do this manually. It's reported in your calculator's results. Just make sure that you get the average for y and not for x. If there is a linear correlation, then the best predicted y value is found by substituting into the regression equation for x. Once you have your regression equation, you can plug in a value for x and get a predicted value for y. This predicted value is denoted as y bar, or y hat, I'm sorry. If there is no linear correlation, don't use the regression equation to make predictions. And when we use the regression equation for making predictions, always stay within the scope of the available data. Note that a regression equation based on old data is not necessarily valid to use now to make predictions. IQ scores were obtained from randomly selected twins separated at birth. For 20 such twins, the linear correlation coefficient is 0.870, and the equation of the regression line is y hat equals negative 3.22 plus 1.02x. Notice that this is reported where they have the b plus ax, so some textbooks switch that around. It's important though to always put the a next to your x. The a number in your calculator is always the slope. In this equation, x represents the IQ scores of the twin that was born first. Also, in the original data set, the 20 x values have a mean of 104.2, so that would be x bar, and the 20 y values have a mean of 103.1, so that would be y bar. So what is the best predicted IQ of a twin who was born second, given that the firstborn twin had an IQ of 110? Okay, so let's go ahead and see, can we even use the prediction equation to make our prediction, or do we have to report y bar? So they told us that r was 0.870, and I need to look up the appropriate critical value in table A6 to determine if there's significant correlation. Now remember, they said that they had 20 twins in their data set. So let's look at table A6. And we're going to go to n equals 20, and we're going to go to the 0.05 significance level. So we'll always go there if they don't tell us otherwise. So at the 0.05 significance level, I have 0.444 as my critical value. So 0.870 is definitely greater than 0.444. So there is significant linear correlation, and I am able to use my prediction line. So y hat is equal to negative 3.22 plus 1.02x, and I wanted to make a prediction about the twin whose sibling had the IQ of 110. So I'm going to plug in 110 for x, and you're always going to plug in for x. So then I work that out, and I have negative 3.22 plus 1.02 times 110, and I get 109.0. And that's rounded up from the original value in the calculator. So this is the predicted IQ score for the second born twin. Find the best predicted number of albums sold for a song that has 100 million audience impressions. In the table below, audience impressions are in hundreds of millions and the numbers of albums sold are in hundreds of thousands. So when we have a table like this, the top row is always going to be our x's and our bottom row is the y's. So this is a ordered pair like that. So we need to enter the data in the calculator, and then we need to figure out what r is, and then that's going to help us figure out if we have linear correlation or not. And then after we find r, we can write our prediction equation by using the coefficients a and b. Okay, so from the calculator, you should get for this data set that r is 0.796. So now let's look at table A6, and going back here, let's look at how many values we had. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have 9 ordered pairs in our data set. So if we go to table A6, I want to go to n equals 9, and I want to go to the 0.05 significance level. So you'll see here that your critical value at that position is 0.666. Now 0.796 is greater than the critical value, so that means there is significant linear correlation, and I can use the regression line. So from the calculator we need to then find A and B, and so you can either write it in slope-intercept form, y hat equals ax plus b, or you can have it switched around, b plus ax. But either way, make sure that you put the a next to x. It is the slope. So I have negative 10.66, that was the b, plus 1.168, that was my a, and I put that next to x. Now they wanted me to make a prediction for the 20, 100 million, so I just put 20 in for x, and I work that out, and I'm going to get 12.7, and that's 100,000 albums.